Good morning, Batalog. In today's video, I'll be talking about a very important concept that often confuses us, that often disturbs us in our sleep. This is a concept of thermodynamics, but in that particular chapter, we are taking an expertise in graphical questions that may be asked in JEE. So, what are the processes that can have that we can have? First of all, let's talk about isobaric process. In this particular process, we should be able to draw all three graphs. First, pressure versus temperature graph. Second, volume versus temperature graph. Third, pressure versus volume graph. For an isobaric process, we know that pressure is constant. In the first part, even if the temperature increases, if we want the pressure to remain constant, the graph would look something like this. Even if the temperature is increasing, the pressure is remaining constant, particularly equal to this point. In a VT graph, if the pressure is constant, we know by Charles' law that V and T are proportional. V and T are proportional. So it should look something like this. A linear graph, as temperature increases, volume also increases. The representation of arrow is very important. As the temperature increases, this arrow represents that the volume is also increasing. PV graph. Again, even if the volume is increasing, we want the pressure to be constant. Again, the graph would look something like this. This is the discussion about the isobaric graphs in all three situations. Let's understand the next part. And let's analyze isochoric process. In an isochoric process, what remains constant is the volume. The, sys- the system's volume remains constant throughout the process. Again, we will discuss all the three graphs. First of all, the PT graph. Second, the VT graph. Third, the PV graph. Right? If the temperature increases but the volume remains constant, our graph should look something like this. Even if the temperature is increasing, the volume is remaining constant. Even if the pressure is increasing, the volume is remaining a constant value. So let's say the pressure was initially P1. Let's say at another time the pressure became P2, but it still corresponds to the same volume. It still corresponds to the same volume. Let's talk about the PT graph. If volume is constant, we know that pressure is directly proportional to temperature by gas laws. By the equation of gas laws, we know that the pressure is directly proportional to temperature. So definitely, if the temperature is increasing, the pressure is also increasing, but they are varying linearly. That that is the because of which reason? The reason is that the volume is constant. If the volume is constant, pressure increases linearly with temperature. Temperature increases, pressure also increases. This is the arrow of representation of a PT graph for an isochoric process. Right? Next, let's move on to the next graph. Let's move on to the next graph. It is where we will discuss what happens in all the three graphs when the temperature is constant. When the temperature is constant, when the process is isothermal. So, first of all, this is a PV graph. When temperature is constant, again PT graph when temperature is constant, again VT graph when temperature is constant. Yes. Now, let's analyze the PV graph when temperature is constant. We know that PV is equals to nRT. nR, that is the number of moles, and the R is the gas constant. While these two values remain constant, temperature might have changed. If it is given to us in the question that temperature remains constant, this particularly this whole term, all three values is a constant, where therefore we can relate P is equals to 1 by V. This is also known as Boyle's law. According to this law, we will draw a graph which looks something like this. If the if the pressure is decreasing, the volume is increasing. A to B. Now, again, the temperature is remaining constant. So, if the temperature is remaining constant, even if the pressure is increasing, the temperature PT graph should look something like this. Even if the pressure is increasing, any any other pressure value will give me the same temperature, same value of temperature. So therefore, we would draw a graph something like this. Next, again we have moved on to VT graph. The temperature remaining constant definitely would imply the temperature would the graph would look something like this. Even if the volume changes, the the corresponding temperature does not change. Therefore, VT graph would look something like this for an isothermal process. Let's move on to the next process. That is adiabatic process. Particularly in this particular process, we often get confused. What is this process? This is the process of adiabatic process. In this process, there is no heat supplied, no heat supplied to the system. The change in heat supplied is zero. So particularly in this process, we have derived a formula PV to the power gamma is equals to constant. Let's if let's say if this particular system has a gas that also obeys the ideal gas equation, the system follows adiabatic condition and the gas is ideal. We can use all these two equations simultaneously. So let's derive, we already have an equation of PV to the power gamma is equals to constant. Let's derive another equation between volume and temperature, and then between pressure and temperature. By deriving these relations, we will form an equation between pressure and temperature. By deriving this relation, we will form an equation between volume and temperature. And through these equations, we will be able to plot the graph efficiently, effectively. So first of all, we got a PV relation. Next, here P can be replaced with nRT by V. So nRT by V into V to the power gamma is equals to constant. This would imply nRT into V gamma minus 1 is equals to constant. This particular nr term is also constant. Therefore, we can write that tv to the power gamma minus 1 is also a constant. Right? We got another relation between which two variables, between temperature and volume, between temperature and volume. So this is a temperature and volume relation, right? Next, let's the last but that we have to derive last relation that we have to derive, that is the relation between, we have already derived pv, we have already derived tv, we have to derive relation between pt. So let's replace the volume by p by nrt. So pv to the power gamma is constant. Replacing volume with p by nrt to the power gamma is equals to constant. We will get a relation that would look something like this. P V can be replaced by nRT by P. V can be replaced by V should be replaced by nRT by P. V would will be P will be 1 minus gamma into T to the power gamma. Now whatever this nr term was, these two terms will are constant. Therefore, it can be replaced and put on the right hand side, therefore giving me a relation between pt, that is pressure and temperature variables, which can be written as p to the power 1 minus gamma into t to the power gamma is equals to constant. There have been multiple questions from in JEE Main on the graph of on these particular topics, and we if we had some idea about these three equations, we would have definitely corrected that question. In multiple places, in all the places, only this particular equation is taught, but it is necessary to analyze all these three conditions. It is necessary to analyze all these three graphs. Let's make all the graph PV, PT, VT one by one. First of all, PV graph. PV to the power gamma is constant. So this graph would look something like this. If the volume approaches zero, the pressure, if the pressure approaches zero, the volume becomes infinite. If the volume approaches zero, the pressure becomes infinite. So this is point A, this is point B. We are moving from A to B. This is a adiabatic graph of PV relation. Again, let's draw a VT relation. Analyze very carefully the equation that we got here is TV to the power gamma minus 1 is equals to constant. Gamma is definitely a value that is greater than 1. This would imply that TV to the power some positive value will be here. TV to the power some positive value. As V increases, the temperature must decrease as they are in inverse proportionality. So the graph would look something like this. As V increases, the temperature decreases. As V increases, the temperature decreases. Right? Similarly, we must have copied these part. Let's analyze a PT graph from this equation that we got here. The PT graph would look something like, would follow PT. We have to follow the same process that we followed earlier. The PT graph, to draw the PT graph, let's analyze this value where P 1 minus gamma by gamma is equals to 1 by T, right? Now, this will be P into 1 minus 1 by gamma is equals to T. Gamma is a value that is greater than 1. So, this whole term will be less than 1 and this whole term will be positive. So, as the T increases, pressure also increases. As the pressure increases, T also increases. Increasing the pressure, temperature is also increasing. Therefore, the graph would look something like this. Temperature increases, pressure also increases. Do we have a clear understanding of all these graphs? We analyzed the equation first. We solved this equation. We formed an equation between P and T. We formed an equation between B and T. We formed an equation between P and V. Then we plotted the points. When we plotted those points in such a way that it is understandable to us why the graphs are being made for PT, VT, and PV, why the graphs are being made in the way that they are being made in PV, PT, VT for an adiabatic process, right? I have brought a question that would explain all the concepts that we learned just right now. And this was asked in JEE in 2021. The question says to us to analyze all these graphs and correct which one is the correct option. In the PV graph, they have drawn two lines. Particularly, this line is adiabatic or not. We have to analyze that. We know that adiabatic in an adiabatic situation, the PV graph looks something like this and not a straight line. Therefore, this automatically is a wrong option. Second, this is again a PT graph where this line represents an isothermal process. An isothermal process is a process where temperature is constant. Definitely, this line is moving forward and temperature is also increasing along with this line. This line cannot represent isothermal process. This is again a wrong graph. In this VT graph, we can analyze the temperature is remaining constant throughout this line. Therefore, this line is isothermal. That is a correct point. In a VT graph, definitely we got an equation that when represented in the VT graph gave us a face of VT graphs which looked something like this, and definitely it is a correct option. This line definitely represents an adiabatic process. Again, for the D option, let's analyze it. PT graph. PT graph, where T is constant and it is an isothermal process. If this line is a line which represents isothermal process, definitely that is a true option because this line has a constant temperature throughout its process. This is a PT. In this PT graph, definitely this line is an adiabatic process. So this is also a correct option. These two were the correct options that we could have marked for the option for the this question to get for us to get this question as among these given options, definitely B is the correct option as both C and D represent the correct thermodynamic processes, the correct graph for the thermodynamic processes. Let's move on to the next question. We will now take a comparison between isothermal process and the adiabatic process. Often we get confused by the isothermal and adiabatic processes and their graphs. Isothermal and adiabatic. First of all, let's analyze the two equations that we have in our mind about the adiabatic and about the isothermal process. First of all, for an adiabatic process, PV to the power gamma is a constant is a satisfied equation. Second, PV is constant is a is an equation that we obtained for the isothermal process as temperature remains constant. All the right part becomes constant. Now, for this particular graph, let's analyze the slope of the PV graph. The slope of the PV graph definitely will be given by dp by dv. So differentiating both sides with respect to V, we will get this side being constant becomes 0. This side becomes dp by dv into v to the power gamma plus gamma v into p is equals to 0. dp by dv is the slope of the PV graph which we obtained such that which which we obtained in this particular equation. So gamma by p v to the power gamma minus 1 is the slope of the negative of this. Is the slope of the PV graph for an adiabatic process. Again, differentiating PV graph with respect to V on both sides, we will get the slope of the PV graph for an isothermal process. This will be dP by dV into V plus P is equals to 0. So dP by dV is equals to minus P by V. Comparing these two equations, we have to analyze which slope is greater than the other. dP by dV for isothermal and dP by dV for adiabatic. We are drawing a comparison between these two graphs. dP by dV for isothermal is minus P by V and dP by dV for adiabatic is minus gamma P by V to the power gamma minus 1. Okay, so first of all, negative negative cancels out. P is on both the equations. Let's analyze if 1 by V is greater or gamma by 1 by V to the power gamma minus 1 is greater. If V is if the denominator is greater, the whole thing becomes smaller. Here the denominator is smaller. As this value is less than 1, so denominator is smaller and numerator is greater. This implies that the whole term will become greater than this value. So definitely slope of adiabatic is more than the slope of isothermal. Next, let's analyze if the slope of adiabatic, if we can understand the PV graph. For an isothermal, it looks something like this, and also for adiabatic, also it looks something like this. Now, which one is isothermal, which one is adiabatic? That we have to analyze through this graph method, through the slope method. As we know that the slope of the adiabatic is more, the slope of the adiabatic is more. The slope between these 2 points when drawn would look something like this. The slope between these 2 points when drawn would look something like this. This slope is a greater slope as the this is a greater slope. Slope 1, slope 2. Definitely slope 1 is greater than slope 2. This would conclude that adiabatic process must be represented by the lower part of the graph and isothermal process must be represented by the upper part of the graph. Therefore, in a PV equation, isothermal is the upper curve and the adiabatic is the lower curve while it is compressing from A to B, while it is compressing, while its volume is increasing. In this particular question, we were given the PV graph of a process. The process is happening in such a way that it is first moving in from 1 to 2, then it is moving from 2 to 3, then from 3 to 4, then the process is moving from 3 to 5, 4 to 5. From 1 to 2, if we carefully analyze, the pressure is remaining constant. It is an isobaric process, as well as we can analyze another important point in this process, that the volume is constantly increasing. So volume is increasing. These are two observations that we could have made through by analyzing this graph in the process 1 to 2. In the process 2 to 3, we have been given in the question that it is an isothermal process. So isothermal implies that the temperature will remain constant, but also it is decreasing in volume. Volume is decreasing. It is a process such that volume is decreasing and pressure is also, sorry, volume is increasing as it was lower on the second point and higher on the third point. The volume is increasing, the pressure is decreasing. From 3 to 4, again, if we analyze very carefully, the volume remains constant. So that it is an isobaric process. What about pressure? What about pressure? The pressure is decreasing. The pressure is decreasing. First of all, we are analyzing all these processes such that we get an idea of what are the informations that we can draw from the given graph. After drawing all these given informations, you will use this information to draw the PT graph. In 4 to 5 process, the process is again isothermal. It was given to us in the question. And the pressure and the volume is decreasing, but the pressure is increasing. So in this case, pressure is increasing, volume is decreasing. These two information were given to us in the question as itself. For this particular process, we have to draw the PT graph. We have come across this question multiple times and it has occurred to us as that how to solve this particular question. This should be the method that you use every time you see that this graph, this question. We will analyze all the processes, right? All the information that are necessary, that we can draw from this graph, that the information that we can use from this graph, and we will then analyze what should be the graph for the given variables. So the variable that is given to us is pt. In the pt graph, what will be the what will the graph look like for the first process, that is 1 to 2, where the process is isobaric. The pressure is constant. Also, the volume is increasing. If the pressure remains constant, the volume is directly proportional to temperature. If the volume increases, temperature also increases. Right? The pressure remaining constant, but it increases in temperature, that would imply that our process is in this direction from 1 to 2, where temperature must increase and the pressure must also simultaneously remain constant. From 2 to 3 process, the process is an isothermal process. In this process, the temperature remains constant, the volume increases, but the pressure decreases. So if the pressure is decreasing, we should draw a graph that should look something like this. But it should be a straight line such that the temperature also remains constant. From 3 to 4, the 3 to 4 graph is an isobaric process. Iso 3 to 4 is isochoric process such that the volume remains constant. And if the volume is constant, the pressure and temperature has a direct relationship. The pressure and temperature has a direct relationship. If the pressure increases, the temperature increases. The pressure in fact is decreasing. The pressure in fact is decreasing. So from this point, I should go to this point, 3 to 4, such that I could analyze that the pressure is definitely decreasing. The pressure was in 3 at 3, the pressure initially was at this point. At 4, it must decrease. Therefore, the linear graph should be downward. From 4 to 5, the process is isothermal, therefore, it obeys Boyle's law, and P isothermal, and the temperature remains constant. So, for the temperature to remain constant, it must be a straight line. It must be a straight line. It must be a straight line such that the temperature is always constant throughout this process. Now, what about the arrow? Should I draw it from 4 to 1 or 1 to 4? Analyze very carefully. The pressure is increasing in this process, so we should draw the arrow in this direction. This will be the equivalent PT graph for the given PV graph. I hope this must have given us an expertise on the thermodynamic graphs. For more advanced question, I'll be making another video that will clarify things further. But this was a basic idea. This was the basic idea behind every possible question of the graph of thermodynamics. Keep studying, keep asking me doubts. Let's meet in the next video.